Let's have a bit of fun till I downfall. My love, if you feel like I do right now, don't say you're on the run to the other side, my love. But you never do. Sugar, there's a reason why we lose. You say you wanna cry, but you never do. Sugar, there's a reason why we lose. You want. Let's have a bit of fun till I downfall. My love, if you feel like I do right now, don't say you're on the run to the other side, my love. You say you wanna try, but you never do. Sugar, there's a reason why we lose. You say you wanna try, but you never do. Sugar, there's a reason why we lose. You say you wanna cry, but you never do. Sugar, there's a reason why we lose. Cold-hearted, but I'm just getting started. My eyes on the target. No, no. You're the battles won, still kingdom come. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. They'll be calling me royalty. inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in the cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. And hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just picking up daisies. Got one too many quarters in my pockets. Counting like the four-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Exaggerated, that's what you assume. The story's over now, I must conclude. I yet still hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear outweighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
Alrighty. I didn't finish the song this time because it was like halfway through. Oh well. So I'm just gonna get straight into the stream because I want to get some stuff done. We have a lot of things we need to get done in this stream. I was walking through the last stream, and there's a few things that I want to change in this, just to keep it running a little smoothly, easy for the user and easy for us as well. A few things I was kind of annoyed with is the fact that in the LLVM module we have to add friends in order to run any sort of things that use any of the objects inside of the private section. So what I want to do instead is hopefully move all of this into its own folder, and then in the includes folder only have one file that you can link to that has like everything in it, and it only has the things you need in it, if that makes sense. So it'll only have the module class, it won't have any definitions, you can't access anything inside of here. This does mean that this section right here, the part that like keeps everything safe when you delete it, might not work, but I want to have I might have a workaround for that. So I'm just going to get started. So instead of LLVM, inside of lib, we're going to actually change this into two different folders. We're going to do source code, right? This is where all of our definitions are going to be, and we're going to move module into here. And then we're going to add another folder, and this will be headers. This will be all of these guys here. So I'll take that, I'll take that, I'll take that, and we'll move all of you guys into headers, like so. Let's go make sure that this works first. So inside of here, instead of include .include module, we're going to change include to headers. Headers. And that should fix all of this. And then inside of headers, go down to module, and we can remove all of this because we don't need it anymore. and change private to public, like so, and remove that. It should still work inside of source code. Yeah, you still access everything. Inside of include, we're going to add a new file. We'll call this one LLVM underscore output LLVM. We'll just call it LLVM, right? .h, because we want it to be a header. We're not going to include this into any libraries or anything like that. Instead, we're going to go ahead and go with we're going to do progma once, and we'll have a class called LLVM module. Leave it at that. It exists, but we don't know what's inside of it. Then we can go ahead and do the 3 different functions that we have inside module, which is these guys right here. Go ahead and copy and paste these into here. All right. What I'm going to do is I'm going to actually split this up a little bit, so we'll have that, and inside of here we'll have. Oh, that's not what I want. Can we? There. Oh, I hate this sometimes. So here we're gonna have classes. Actually, you know what? Let's do it this way. Let's go like this. We don't need 2 different things. We'll do classes. We'll do functions. And then we'll do here, we'll have definitions. And this is just so we can kind of find things a little easier. And inside of definitions, we can go ahead and steal all of this and put this inside of LLVM.h like that. So this is basically everything that we included in the last one, just inside of us one small folder that we can then go to our main source code file, and instead of doing module.h, we'll include LLVM.h. Hopefully this works. Fingers crossed that this actually runs. Should do the exact same thing that it did last time. Perfect. And then if we go to our output file, inside of build, debug, program language YouTube, test.ll, and we should have, sweet, we have that inside of it. Perfect. The only thing that I've noticed here is that I don't think it ran the, let's see. So inside of CPP we have, where's our, yes, this is our thing that undoes everything, right, when you delete it. So what I want to do, I'm going to run a test and see, I'm going to change this real quick. I'm going to run a test and see if this actually like does run. I don't see why it would, to be honest, because there's like no way for the actual or the program to know that this exists as of right now, but I might have a way to fix that. Who knows? Maybe it's smart enough. It's, yeah, see, nothing printed out. So if I were to go, so what we're going to have to do is we'll have another file here. And we'll call this, I'm going to minimize this tab over here in my second window. So we'll have void, and this will be LLVM underscore delete module. And we'll take in an LLVM underscore module pointer, call it module. And this will, in turn, take in a module. We'll come back to our header file, and we'll also paste it here. Then inside of here, right? And we can close all of these down. We don't need to see all the definitions. We will delete module. That's literally it. I'm just going to delete the module. So then, yeah, so this basically just deletes the module safely. Hopefully, if I run this now by going to our programming language, and I'm actually going to pin this to the front so we don't lose it. But now if I do LLVM underscore delete module, and run in our module, sweet, then it actually does delete everything properly. That's all we need. That's all we need to do. This makes things so much easier. Essentially what I did is I only included one file to link to. This one file has everything that you possibly need, but nothing extra so you don't break any code. And then inside of the library itself is where we kind of do all of our different folders and stuff, make sure that everything's organized so it's easier to add things, find things, change things. It's a little bit of a mess right now, but this is what the user is basically going to see. They're basically just going to have one file that they include that has everything in it. Makes things so much easier. And of course it has programmable once, so this means that you can add it to multiple files without it getting upset at you. We also can create our file. The only thing that we changed was the deletion thing. This just keeps it safe, right? Because if we deleted it normally, if we did normal delete module, right, this technically still works, but it leaves a lot of excess. Like if you were to create anything that any sort of global variables or functions or anything like that, that will still remain on the heap. And I'm going to explain a bit about that. Actually, let me go to, we're going to bring up our paint just because I'm going to kind of show you guys what I mean by this. So, pencil, essentially, when you create a function using new, right? So you have like your like name identifier equals new name, right? Essentially this is creating it on the heap, right? There are two kinds of memory, and the heap basically is a dynamic memory that all of your programs share. And when you want to create something new on it, it allocates a section of that memory and says this can be only used for that, right? Something exists here. It then gives you an ID, right? And that ID can be used to find it later on. This is a pointer, right? It's pointing to that spot in memory. In order to, now you can get rid of that ID if you want to, but that memory is still allocated. Your computer doesn't know that that memory is not being used anymore if you get rid of that ID. So instead you have to do delete and then the ID. And essentially what that does is it tells the memory we're not using that anymore. Remove it so other programs can use that. If we don't do this, then we run into an issue of memory leakage, which is when the computer says, hey, we have no more space left, right? We've used all of this space here, but it's not actually being used. It's just there. It just exists, right? And that's a problem. When I was going through I was watching the last stream that we did, I actually ran into that issue where I didn't notice I had a memory leak. Most of the time, the memory leak is not going to actually happen. And we'll see what we mean here. So under create module, you'll notice we do our new thing. We create it on the heap. And then if something fails, we get rid of the ID, but we don't delete it. So this still exists somewhere, right? If for some reason it did open everything and there was no error, then it just returns the ID, and then we can delete it later on, like we are doing in our function here, right? We still get the ID and then we delete it later on. But if that ID is not real, then we can run into an issue. So what we're going to do is, instead of just returning null pointer, we're actually going to open this up into a parenthesis, right? Into a set of instructions rather than just one instruction. And we're going to actually delete temp module. This will keep things safe, make sure there's no memory leakage, because again, we don't need this anymore. There was an error. And then we can return null pointer. Or an ID that doesn't have an ID, basically. Also inside of here, you notice that we check if there's a null pointer. And this is just safety thing, because if it's a null pointer, then we can't actually run any of these functions, right? That would break it. I also want to check here. We'll do, or actually that doesn't matter. This doesn't matter either because it's actually running in the module. Sweet, okay. So now, inside of our value object here, I want to go ahead and add, we don't need this. We don't need this, but we can set this to public. Okay. So inside of here, we actually create a global variable, right? Now we need to add a generation function. So when we do our generate here, it can actually generate into the module. The way we're going to do that is inside of value.h, we're going to have a virtual, I could spell, function. So this will be a virtual function. Essentially, there's going to be a different definition for each kind of, or for each subclass. So this is a subclass because it derives from that class. So we can redefine this definition whenever we run that code, right? It can do something different with the different objects. And we'll call it generate. We are going to need to get a pointer, so we'll have to do include fstream, right? And we're going to need an output file stream. We're going to pointer of that, right? It's going to be pointer. We'll call this output stream. And so this output stream is going to be where, or where we actually output to, essentially, because this does not know that there's going to be an output stream of some sort, right? Or it doesn't know where we're outputting to, so we need to tell it where we're going to output to. And then we're going to create another file, and we'll call this value.cpp. Is going to be where all of our source code is. And we'll include value.h so we have everything. Okay. So inside of here, we'll do LLVM void LLVM underscore value object colon generate. We'll include the OF stream or output stream. We're going to define it in here. Did I not do this right? Definition with void . Incompatible. What are we incompatible with? Oh, it's under protected. That's why. Should still. Oh wait, no, I'm dumb. This is a pointer. There we go. Okay. Okay, so the way that LLVM outputs files, right? Let me go ahead and do a test.ll, right? So essentially, we start with the name, which always starts with an @ symbol, equals, and then any external data, right? So we'll have external, or like, we'll call these arguments, right? This can tell if it's like including it from another file, if it exists in this file, if it's private, or anything like that, right? Then you have your data type, and then you have your initialized value, right? The way I am going to do this is, okay, so data types can be like I32, I64, things like that, right? Value can be a number, it can be sort of number, right? So like 10. It can be a character, so like character, right? Or it can be an array of characters, an array of anything. But this is just, that's the general layout of this. So we need to kind of do that with this here. Now all we have inside of this as of right now is, we come back to, let's close here. We come back to the value object, right? All we have is our data type, our name, and our extra data. The extra data is going to have a lot of the extra stuff, like all the arguments and stuff. But right now I don't want to worry too much about it. Let's first go off with the let's create a function here, right? We'll do it in we'll do it in data type or value, because why not, right? Everything's going to be included in here anyways. Probably change this later. We're going to have a definition called, it'll return std string get data type string, and then we'll take in an unsigned char called data type. That's our data type. Also put it in here, like so. And we'll use a switch method, right, of data type. This basically is a bunch of if statements, like if it's this ID, if it's this ID, if it's this ID, but it runs using math, so it'll be a lot quicker than checking every single possible combination. I'm also going to use a define up here, and we'll call this one get case X and Y. This basically just, whenever this is placed, you can put in your two arguments, and then it will replace whatever this is with whatever code you put after it. It's sort of like a text replace, like a find and replace sort of thing. So then we'll do case X return Y, right? So we can do case, and we're actually going to want to include, hold on, include // or headers definitions. So we'll do get case. I'm gonna do LLVM underscore void. And we'll return void, right? Simple as that. And to make things a little bit more easy on myself, I'm going to do that so it forces me to have a semicolon at the end, just because it makes sense to me to have a semicolon at the end of everything. So we'll do get case LLVM underscore I1, we'll return I1, right? You guys see the pattern that I'm going with here? So we'll do this. This will be I8, I16, I32, I64, float and double. And then, so then we'll do 8, 16, 32, 64, float, and double, like so. It's supposed to be 16. Actually, this is supposed to be 8. I'm going to do I8, I16, 32, 64, float, double. And I actually don't want to return this. So we're going to get std : string, right? Well, this temp string. We'll do temp string equals y. We'll have z here, we'll have y here, and z, and then between all these we'll do temp string. So I think I'm going to be able to reuse this later, but we will see. Like that. And we'll do default return. So this just returns a basic one, which means that there was some sort of error when coming up with this, right? Then we'll do another switch, right? Actually, we're gonna have to and 15 because I forget that we have the or thing that we have in here where we add pointers at the end of it. So we'll do switch data type and 48. This will get the last two ones, or the last two bytes, which will tell if it's a pointer or pointer. Then we'll go and get case. Actually, I'm going to do plus equals z. So this, we'll do pointer, that, and we'll do it again. And this will be pointer. We'll do that. And then we'll do case. Case 48. In the off chance that there is something like this happening, then we will return that. So in the off chance that they're both on for some reason, which they should never be, then we'll return an error as well. So there's also another way to like double check if things exist, but it'd just be faster to have its own data type later, which we'll see. Definitions. No, so then we'll go back to the generate function, right? We can do output file or output stream, right? Into it, we'll do name. What do we call it? What do we call it? Yeah, name. Oh. Wait, no, so we're just gonna do that. What are we expecting here? Okay. So it's not gonna do anything just by default, but this one on the other hand, we'll have an override for it. So we'll have void generate stdof stream to put stream override. This just makes sure that we're overriding something and that we're not just having this as its own definition that will never actually get called in the options, like I actually misspell it or something. See, it gets an error. That I don't need the override here. Actually, yes, I do. LLVM underscore global. How the fuck did I spell it? Generate. There. Okay. Now we'll do OF, or yeah, the output stream. We're gonna send some data into it. First thing we're gonna do is name. Actually, we need to add a @ symbol first, because all global variables or functions, anything in the global state, will have an @ symbol in front of it. So we'll do name followed by an equal sign followed by get data type string, data type followed by no, stop it. We don't even have a way to keep the initialized data, do we? I think we can't initialize it. You could do like union, right? And then we'll have init data underscore int, and first be an int. Actually, this will be long. Then we'll do double init data underscore float. We have our data if it's an int and our data if it's a floating point. We'll just do that for now. It goes by space. Leave it at that. And then the first bit of our extra data will be, so we'll do if and one, or if extra data, and we'll get the first bit, so we'll have to and one. If whatever that equals is equal to 1, right? Then we can stream. This will be our floating point, so we'll have to do to string std to string, and we'll do init data dot, or init data underscore float else. Instead of doing the float, we'll do our int. Or whichever one we want to do for some, or yeah, we'll do it that way. Now, actually, we need to, so what we're gonna do is yeah, we'll do it that way. Just pre-calculate it. Is it the smartest way of doing it? No, but I'm gonna do it that way anyways, you know? Then you can go ahead and put stream a new line character, I guess. Global. Which we want to do this. This is just a default. We'll actually add like global or external or anything like that later. Okay. So this is just the basics of it, right? I'm gonna change some stuff later. I just want to get this working, right? We have this, we're gonna need a name, right? So it will come back here, we'll go to module.cpp, or no, hold on, we're gonna, yeah, instead here to the module, and we'll do std string name, like so. Let me create our global variable, and inside of the LLVM thing, we'll also change that up here like that, and inside of here we'll call this one test. We'll have this be our test, right? I'm gonna keep this at I32 for now. We'll add pointers probably in the next stream, but I don't know, I might add it in this stream. I don't need this. Is that a module.cpp inside of the generate function, right? Instead of this, I'm gonna have colon. So the colon at the beginning just symbolizes it's a comment. for the LLVM code. We'll do this is, or do, here's, we'll do 1, 2, 3, 4, 5 global variables. I am so not able to type right now. Okay. Then we can do for size t index is equal to 0. Index is less than global variables dot size index plus plus. So this will iterate through every single size, right? Or through every single global variable here. Then we'll do global variables index dot generate with the memory location of our output file stream. Theoretically, this should work. I also want to change here inside of the global variable function. We'll have name, and we'll also do a temp var name is equal to name. Theoretically, this should work. All right, let's run this. Hopefully this works. Okay, well that's promising. That is not, oh, because I'm a dumbass. So, sweet. Okay. Okay, well, okay. What is going on here? Well, let's try this first. Let's go. So it's working technically. We'll do /n to go down to the next page, and then okay. So test works, right? This is the name equals global, and then this is where it breaks. So if we come back to value space, then get data type as a string. And I'll put a, actually, let's go back to module CPP first. Take it as on char, data type, send data type through. Temp variable, data type, and that's what we call it here, right? Yeah, which is on char. Let's get rid of these first. Back to here. Okay. want to see out what the data type is. Include string, or no, IO stream. Data type. And we'll convert this to an integer. Like that. What on earth is the data type? 5. Okay. 1, 2, 3, 4, 5. Oh, hold on. That's the problem. What's going on? Size type. What did I do? I don't understand why we're getting an error here. In string. Well, okay, so we outputted. Do that, right? Oh, return temp string. Is that it? Yeah, that's it. Okay. Don't save. Open that again. There we go, I32, sweet. Okay. So now I can get this back. And I want to add initial data now. So we'll go ahead and go back to here. We'll add a void pointer, right? Data. And this is going to point to our initial data value. Reason we're doing a void pointer and not anything else, because a void pointer can point to anything. So you could have it point to an int or a double, and basically the data type chooses whichever one it is, right? So we'll go ahead and we'll do first thing I want to do is have a, we'll go here, we'll have a bool is data type float, unsigned char data type. This will return if it's a float or not, some safety checking or not, right? So if it's a float or a double, it'll return true. Then up here we'll do bool is data type float, data type. We'll do it right under here. And then we'll do if data type and 15 is less than LLVM underscore float. we can return false. Right, because if it's anything less than a float, or less than 7, then it's not a float, right? If data type and 48, right? So if the last 2 bits are on, which is what we want, if the last 2 bits are on, is greater than 0, right? So if it's anything more than 0, if the last 2 bits are on, then we can return false, because we know that's a float, it's a pointer value, right? Then else return, or we'll just go ahead and return true. That means that it's not a pointer, but it is a float. So we'll come back to here, and we'll do if is data type float data type. Also, we're going to get a void pointer init value, right? Do the same thing in this, and double check its init value, like so. Module CPP, if data type is a float, right? Then we'll do extra data we'll do temp var dot extra data or equals extra data temp var extra data or 1. We'll turn that bit on. And then temp var init data float equals as a double pointer init value. So whatever's at init value will be put into here. Else, we're just going to do this. We'll set this as a long pointer. Theoretically, this should work. So I come back to here and then I add, so I add a int or a long init value equal to, we'll say 10. Then we'll give it the memory location of init value. Theoretically, this should work. Don't give me any errors. Sweet. Here's 10 with a bunch of zeros at the end. Why is it a bunch of zeros at the end? It shouldn't be. CP generate value. Extra data and 1. before we print this off, let's just do std cout. Wow. Okay. So for some reason it's still I want to see if maybe for some reason this part is the part that's messing up. It's not. So it is the output section that's messing up. I have no idea why this is happening. Alright, if I can get this figured out in the next 5 minutes, it'll be great. Because I want to end the stream in 5 minutes. Why are we... We'll do std cout. Obviously, and so I just want to see what it outputs, because if it outputs 1, yeah. So if it's equal to 1, wait, but it shouldn't be equal to 1. What if I... I want to double check. You're not getting any 1 here. So why is it equal to 1? It's not setting it to 1. Oh. Int, maybe? I don't think that's gonna, yeah, that's not gonna do anything either. Hello, Mindtraptive. I don't know how long ago that message was sent, but hello. Getting messages too. I have no idea what is possibly going on we'll do this. We'll do and 254. Theoretically, I should not make it so the last bit is not on. I'm on right now. Extra data is equal to 0. That's that. Let's see how data type anymore. If I did this, still gonna equal 0. The thing is, I don't know why it's not setting extra data in temp var to anything. It's clearly setting initialize data to something, but not the temp var. Or not the extra data. See, this is what I mean by this is like the main thing of programming. Well, now that it's 0, did it like set it out normally? At least, yeah, at least it printed it out normally now that it's 0. I don't understand why it's not setting extra data to 1 though. I mean, this is running, right? This is running, right? Yeah. And then if I do this, should set it to 1, but it doesn't, it's still 0. Let's just see what happens when I print that out. Should be 1, right? Yeah. Oh, because I'm stupid and I'm putting two equal signs. It's right in front of me. I'm putting two equal signs. So then, yeah. Because I'm stupid. There we go. But then if I set this to a, say I set this to LLVM underscore float, and set this to be a double. And I should output, yeah, float with it. Sweet. There you go. Basics of global variables done. It was way harder than it needed to be. I'm gonna go and end the stream here just because I am tired and I want to take a break from this. But just to recap what we've done over the series or over this stream, we added everything to a single file in the include file. That way people can compile the library and then only include one file when they want to link everything. And it keeps everything that we don't want them to access hidden. We created a value object which can generate code, and a global value which overrides that generation code and has its own thing. It can store some extra data, a name, and an initialized value. And then we add a way to create that and properly implement it before generating it. Inside of the generation code, I just want to kind of explain a little bit more because I noticed I haven't explained it too much. Essentially what we're doing is we're checking to see if module is a fake module, right? If it doesn't actually exist. If it is a true module, then we'll go ahead and we'll create a global variable, set its data type to whatever the data type is here. I need to do a bit more type checking to make sure that data type is a correct type, right? Like it is an actual type that we can use. Then we do, we set the name to the name that we want it to be. Then we check, and if the data type is a float, then we go ahead and set the float byte on and put the data type in as a float, or the initial data in as a float. Otherwise, we set the type to 0, which means it's not a float, and set the initial data to an integer. And then we add it to the stack, or to the vector here, the global variable stack. Then in when we generate it, we go ahead and we output the name with an @ symbol in front of it, so LLVM knows that it's a global variable. And we set it equal to the data type, and then the value of the data type. We can remove the debugging feature here. Then the value of the data type, and depending on if it is a float or an integer, it'll print off its corresponding float or integer. And we can actually add, let's add another one of these as well. So let's add a second one, right? And we'll have this one be called test2. We'll do it of I32, and we'll set it as an, we'll have our value be a long of init value long with 43 as the value. So we'll do init value long, then we create that. We'll run this, and inside of here, set up our test, and we have test2 as well with the value of 43. So it works. Everything is functional. In the next one, I want to add a way to identify all of these by adding a LLVM value ID. I didn't actually get to it in this stream. I know I said it in the description that I was going to get to it. I did not, but the ID is going to be basically be used to identify these and use them later. And then yeah, we'll see what we do with the next one. I think in the next one I want to add parameters like having external stuff, private or public, and then maybe get into a little bit of function stuff. We will see. Thank you all for coming to the stream, and I will see you guys in the next one, hopefully. I'm sorry that this one was not very talkative, but I wanted to get a lot of work done. So see you guys in the next one. Hopefully it'll be a bit more interactive.